This video covers section 11.5, Exponential and Logarithmic Equations, Objective 2, Solve Exponential Equations. In practice 1, we solved some exponential equations, 3 to the x equals 5, and we simply converted those into log form to solve those. The other type we saw was if you had the same base on both sides, like 9 to the x equals 27. In that case, we would get a nice solution out of it by writing them with the same base. 9 is 3 squared, 27 is 3 cubed, so we get 3 to the 2x equals 3. If a to the u equals a to the v, we drop off the bases and we just say u equals v. So 2x equals 3 or x equals 3 halves. So that's the solution to that equation, because 9 to the 3 halves, the 2 in the denominator is the square root, which is 3, and cube that, which is 27, giving us 27. However, in many situations, we cannot write each side of the equation with the same base. In this case, we simply convert to log form. If you solve 3 to the x equals 10, there is not a nice integer for us to raise 3 to get 10, because 3 squared is 9 and 3 cubed is 27. So the answer to this is an irrational number, and we write it in log form as x equals log base 3 of 10. Remember, your logarithm is always equal to the exponent, and the base is 3 in order to get 10. So we call log base 3 of 10 the exact answer. If we need to estimate it for application reasons, then we use the change of base formula. Remember, we can use the change of base formula with base 10 or base e. They will both give us the same answer. I will use changing to base 10. So to solve these and write them exact form, we locate the exponential portion, 2 to the x, and say that x is the exponent on the base of 2 to get 7. And logarithms equal exponents on the base of 2 in order to get 7. So this is what we call our exact answer. If we need to estimate it, we go right to the change of base formula, log of 7 over log of 2, and estimating that, log of 7 divided by log of 2 gives us 2.807. Keep in mind on the exam, I will not allow you to use a calculator, so you won't be estimating these on the test. So here's a practice problem for you to try. I encourage you to press pause on your video and work this out, and come back when you're ready to see the solution. Now that you've had your chance to work this out, I'll work this out with you. 4 to the x is the exponential portion, which tells me the exponent is x. On base 4 in order to get 20. That is our exact answer. If we want to approximate that, we can do the log of 20 divided by the log of 4. And that will get us Log of 20 divided by log of 4, 2.161. Example 4, we need to be able to isolate the exponential portion. So that's 4 times 2 to the 3x. I need to get rid of that 4, so I achieve that by dividing both sides by 4, giving me 2 to the 3x equals, and we'll write that as 5/2 now. Now we see the exponential portion, 2 to the 3x. The exponent is 3x. The base is 2 to get 5/2. Now to solve for x, we divide both sides by 3, and that says that x is equal to the log base 2 of 5/2, all divided by 3. So there's our exact answer. In the event that you want to estimate this, we would say that this is log of 5/2 divided by log of 2 divided by 3. Well, that 3 goes down in here. The denominator is 3 times log of 2. If I want to estimate that, do the log of 5 divided by 2 divided by 3 log of 2. And that gives us 0.441. If we were asked to estimate it. Here's a practice problem for you to try. I encourage you to press pause on your video and work this out, and come back when you're ready to see the solution. Now that you've had your chance to work this out, I'll work this out with you. Before we convert to log form, we have to see what the exponent form is. 5 to the 8x times 7, we need to get rid of that times 7. So we have 5 to the 8x equals 70 divided by 7, which is 10. Now we see the exponent and the base. The exponent 8x, the base of 5 in order to get 10. Solving for x, we divide both sides by 8 and get the log base 5 of 10 divided by 8. There's our exact answer. And if we wanted to estimate this, log of 10 divided by 8 times log of 5. Our change of base would have to be log of 10 divided by log of 5 divided by 8. and that is 0.179 approximately. Example 5. 4 times e to the x plus 8 equals 5. The exponential portion is e to the x plus 8. So I have to divide both sides by 4 and get 5/4. Now I see that the exponent is x plus 8 on the base of e to get 5/4. Now we like to write that as the natural log of 5/4. Anything log base e is the natural log. So we subtract 8 from both sides and write -8 plus the natural log of 5/4, giving us our exact answer. Now we don't need any kind of change of base formula to estimate this one because we have the key for natural log of 5/4. So if we were asked to estimate this, we would say the natural log of 5/4 and that's then 8 taken from. And so we get around -7.7. -7.777. And here are 2 practice problems for you to try. I encourage you to press pause in your video and work these out and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. In letter A, the exponential portion is isolated, e to the 2x. The exponent is 2x, and the base is e in order to get 9. So we have 2x is equal to, the log base e is the natural log of 9. Solving for x, we divide by 2 and get x is equal to the natural log of 9 divided by 2. That's our exact answer. If we were asked to estimate this, we would take the natural log of 9 and divide that answer by 2. And we would get 1.099. Letter B, the exponential portion needs to be isolated. So we have to divide by that 3 because it's being multiplied. And then we have e to the x minus 4 equals 20/3. The exponent is x minus 4. The base is e to get 20/3. Well, we call that the natural log of 20/3. Solving for x, we have to add 4 to both sides, 4 plus the natural log of 20/3. That's our exact answer. Our approximate answer would be 4 plus the natural log of 20 divided by 3. Gives us around 5.897. And again, we would estimate this if it was an application problem, which is what the next section is devoted to. or I should say next objective, which is objective 3, solve equations involving exponential models. And this concludes the video for section 11.5, exponential and logarithmic equations. Objective 2, solve exponential equations.